Okay, we're gotomath.com working some calculus. We are in doing continuity and one-sided limits. And of course, if you click that button, this is the video about that button. Click the video button and then click the video button on an introduction of continuity and one-sided limits. All right, well, anyway, let's move over to the whiteboard and talk about this real quick. And what I'm going to do here is I'm going to go ahead and just kind of sketch up. I'm going to attempt to draw a straight line. We're going to just kind of, wow, sketch up a picture of these concepts here on continuity and one-sided limits, which we've kind of done in the numerical section. All right, let's do, what color do we want to do? Green? I don't know, we'll do green. How's that? Why not? But what we're going to, and that's kind of over exaggerated there, obviously. And we're just going to kind of sketch up a picture here of a piecewise defined function. We'll say it's piecewise defined, and then we'll put an open hole there, and we're just going to kind of go through all the most of the possibilities anyway. How about we do it down here, and then let's put in a vertical asymptote right here. Now I could actually use some kind of program to graph us out a nice picture, but I don't know, there's just something about hand drawing a graph that I just find a whole lot more, I don't know, educational. Seems like it just gets everybody involved when we draw stuff by hand. Okay, let's talk about continuity. The word is continuity. Continuity and what it is. Okay, it's a real simple concept. Let's think of it this way. If I put my pencil on this line, okay, and I'm drawing the line and I want to get to this line, if I have to pick up my pencil to get to this other side, then right here, and what could we say? This is -10, we'll say, that it's not continuous. Okay, this is not continuous. If I have to pick up my pencil and get to the other side right here, then it's not continuous at -10. Okay, so this is not continuous. So I'm following the line right here. Now, there's a hole here, or a missing point. Now, I've over exaggerated this, obviously. But once again, if I've got to pick up my pencil to get to the other side, then it's not continuous. And we'll say that this is -6. We'll say this is -6 right here. All right, then it's not continuous at -6. All right, it's not continuous. Now, of course, I go along the line here, and once again, I've got to pick up my pencil to get to the other side, right? Then it's not continuous. And what could we say this is? 2. We'll say that's 2 right there. So it's not continuous at 2. Now I pick up, or I go along, and of course this goes down to -infinity, right? Just keeps on going. We got a vertical asymptote right here. But to get to the other side, okay, in order to do that, I'm going to have to pick up my pencil, okay, pen, whatever, to get to the other side. And we'll say that, what could we say this is? We'll say this is 6 right here. All right. So we know that it's not continuous at 6, okay? So it's really a simple idea. If we got to pick up and go to the other side, then we know it's not continuous. Now, there's actually a definition of continuity, okay? There's an actual definition of continuity, and 3 things must be satisfied in the actual definition. 3 things must be satisfied. I'm not sure we're going to be able to read this whole deal, but The definition of continuity at a point, a function f is continuous at c if the following three, now I'll just tell you what this word says, conditions, and then it says are met. So f of c must be defined, the limit of f of x as x approaches c exists, and the limit of f of x as x approaches c is actually equal to f of c. So let's first look at this one right here. F of c must be defined. Alright, f of c must be defined. So we'll just write that right here. F of c, right, must be, well, it has to equal to some real number, must be defined. Now, take for example this right here, okay? If we were looking at f of negative 6, well, f of negative 6 is defined, and if we took negative 6, plugged it into the function, well, we would get this point. There's a point right here, and I'm not sure what could we say that is. 5, 6, we'll say it's 5 right here, okay? Okay, so the graph is obviously not to scale, but anyway, so you would get like 5 out, right? But where is it, where's it fail? Let's see, so let's look at the next condition here. The limit of f of x as x approaches c exists. Let's take a look at that. The limit of f of x as x approaches c exists. So if we were to take the limit as x approaches negative 6 of f of x, well, remember how we do this, right? First we come in from the left, come in from the right hand side, and it's actually equal to wherever this hole is right here. I don't know, what could we say this is? 2, 3, we'll say this is 3 right here maybe. Okay, so this is actually equal to, let's say, 3. Okay, now, so far so good. Let's look at this condition here. The limit of f of x as x approaches c is equal to f of c. What does that mean? Well, let's go back. Okay, basically all that means is that these two numbers right here must be equal to each other. Must be equal to each other, and guess what? They're not. So that condition, that last condition down here, is not met, and therefore it's not continuous at negative 6. So if we're talking about the definition, right, we have to go by this definition of continuity. And so this one here down here, the third one fails, right? This one fails down here, and therefore we can show mathematically, without just looking at a graph, that that it's not continuous here. Now if we were to look at this one, what would fail? Well, the limit doesn't exist first off, and this doesn't exist, right? F of negative 10, if we were looking at that, f of negative 10, okay, well, that doesn't exist. We're just going to say DNE here for does not exist. So that guy fails immediately, right? There is no y value associated with this graph at when x is equal to negative 10. So the first one fails. Same thing goes here. F of, we'll look at that up here. First off, f of, okay, negative 2, f of negative 2 exists, and and it looks like it's 3 right here, we'll say. It's 3. But the limit as x approaches 2 of f of x, okay, this does not exist, right? The limit does not exist. You know, coming in from the left hand side, now remember you have to look in the numerical section about this. Coming in from the left hand side, it's negative, or it's 5, and then coming in from the right hand side, it's 3, and both those numbers must be the same in order for that limit to exist, but they're not. So therefore that fails right there. Okay, that part right there fails. So anyway, and of course you can see here it's not continuous. What's going to fail first? Well, this up here, right? There is no f of 6. That's not in the domain, so that does not exist either, right? So that fails. That first one fails. All right, so it's pretty easy to kind of tell how to tell for continuity. Now, one-sided limits. What exactly is a one-sided limit? One-sided. Well, we've been talking about one-sided limits. One-sided limits. For example, this guy right here, if we was looking at this and we were asked to find the limit as x approaches negative 10 of f of x, but we want to know just this part here. All right, so we'll say that this is 2 or something like that. We would say coming in from the negative side. So we put a little negative sign right here. We'll put a little negative sign right here. And this means we're coming in from this side here, right? And that's, we'll say that's 2. What the heck? We'll say it's 2 right there, okay? So that's coming in from the left-hand side, and then coming in from the right-hand side, okay? Um, we'll say that's 5. I don't know, it doesn't look like it, but we'll say it is. So if we were coming in from the right-hand side of negative 10, we would say the limit as x approaches negative 10 of f of x, and if we're coming in from the right hand side, we put a plus sign. We put a plus sign. So we've been talking about one-sided limits, especially in the numerical section. We first talked about how to find the limit numerically and then just kind of guess where they're both converging towards. We did that. We did left-handed limits and right-handed limits, and of course if the left-hand side is equal to the right-hand side, both these numbers are equal, which in this case they're not. But if both of these guys are the same, then the limit exists, and it's whatever this number is. All right, so it's kind of a sloppy thing going on here, but that's the way things are sometimes. Um, anyway, 12 minutes so far. So that's just a rough sketch, basically, of continuity, and we've been doing one-sided limits, and so that shouldn't be really anything new other than the notation here is different, and we'll be seeing that in the problems coming up. Okay, so good luck on that, and remember where we are. We're at gotomath.com. See you there. Bye.